Hi everyone, today I'll be going over A4, which is rational expressions. So a rational function is where you have a polynomial divided by another polynomial. And the domain is the possible values of x. So in this first section, we want to find the domain of the expression. In number 1, all we're going to look at is the denominator, because when we divide, we cannot divide by 0, so we're going to set the denominator, which is x squared minus 8x plus 16, not equal to 0. And in order to find what x can't equal, we can use the x method. So on the top would be 16 and on the bottom is 8. So the two numbers that multiply, negative 8. So the two numbers that multiply to positive 16 and add to negative 8 are negative 4 and negative 4. And x is going to go on top. So you can use the x method, or if you notice, this is a perfect square trinomial. So this will factor into x minus 4 times x minus 4. And that cannot equal 0. So now we want to solve for x. Since they're both the same, we can just solve one equation. So x minus 4 cannot equal 0. We're going to add 4 to both sides, so x cannot equal 4. And this will be the domain. For number 2, we have a radical. We have square root of 2x minus 5. So the number inside the square root, which is 2x minus 5, this has to be positive, so that means it has to be greater than 0, and it can also equal 0. So that means our setup would be 2x minus 5 is greater than or equal to 0. So then to solve for x, we're going to add 5 to both sides. We get 2x is greater than or equal to 5. And when we divide by 2, we get x is greater than or equal to 5 over 2. So that means x can be any number that's equal to or bigger than 5 over 2. For number 3, we have a radical inside a denominator. So if you remember, the denominator cannot equal 0, and for radicals, the number on the inside, so the x plus 2, this must be greater than or equal to 0. So that means x plus 2 has to be greater than 0. It can't equal 0 in this case because we can't divide by a negative. So to solve for x, we're going to subtract 2 on both sides, so x is greater than negative 2. Next is simplify, multiply, and divide rational expressions. So if you have a division problem, you want to rewrite it as a multiplication. Then you want to factor, cancel out as much as you can, and rewrite as one fraction. So you're going to multiply the numerators, you're multiplying straight across, and then same with the denominators. So for number 3, we're just simplifying because there's no multiplication or division, and we want to factor each part of the problem. So x squared minus 9, this is a difference of 2 squares. So that's going to factor into x plus 3 times x minus 3. And in the denominator, we have 4 terms, so we want to factor by grouping. So we have 2 halves here. So in the first 2, we can factor out an x squared, so we're left with x plus 3. And in the second 2, we can factor out negative 9. X plus 1. In the second 2, we can factor out negative 9, so we're left with x plus 1. And then in the denominator, they both have x plus 1, so we can factor that out. So we have x plus 3 times x minus 3 over x plus 1 times x squared minus 9. In some cases, you can stop here, but for this one, this is a difference of 2 squares, so we can factor that into x plus 3 and x minus 3. So in the denominator, we have x plus 1 times x plus 3 times x minus 3. Next, we want to cancel out anything that we can. So on the numerator and denominator, I see an x plus 3, so I can cancel that out, and an x minus 3, so I can cancel that out as well. So in the numerator, we're left with 1, and in the denominator, we're left with x plus 1. For number 4, this is a division problem, so first I'm going to rewrite it as multiplication. In order to rewrite as multiplication, we're going to change the division to a multiplication sign, and we're going to multiply by the reciprocal. So x squared minus 14x plus 49 over x squared minus 49 times x plus 7 over 3x minus 21. So the numerator of the first fraction, so this one here, this factors into x minus 7 times x minus 7. You can use the x method, or if you recognize that this is a perfect square trinomial. The denominator is a difference of two squares. So let me just put PST, and then this one is dots. So that's going to be x plus 7 times x minus 7. The numerator of the second fraction, we can't do anything, so we're just going to leave it as x plus 7. And in the denominator of the second fraction, we can factor out a 3, so x minus 7. Next, we want to see if there's anything in the numerator and denominator that we can cancel out. So there's an x minus 7 that we can cancel out, and another x minus 7, and also x plus 7. So everything except a 3 in the denominator is left, so this is going to be 1 over 3. Next is adding and subtracting rational expressions and simplifying complex fractions. So first you'll want to find the least common denominator and multiply where necessary. Add or subtract the numerators and simplify if possible, and factor the numerator and denominator if possible to see if you can simplify anything. So in number 5, we're first going to look for the least common denominators. Our denominators are x minus 5 and 5 minus x. They both look really similar, but there's a negative sign, so if it helps, you can rewrite this as negative x plus 5. But we want this to look like x minus 5, so we can factor out a negative from that, and we get negative times x minus 5. So the least common denominator is going to be negative x minus 5. So that means to the first fraction, we want to multiply by negative 1, since that's what's missing from the LCD and the original denominator, and then the second fraction, we don't have to multiply anything. So next we're going to multiply. So 2x times negative 1 is negative 2x, and our LCD, or our denominator, is going to be negative x minus 5 minus 5 over negative x minus 5. So then we can combine this into one fraction, and we get negative 2x minus 5 over negative x minus 5. And there's a lot of negatives in this problem. So in the numerator, we can factor out a negative. That'll be 2x plus 5. In the denominator, we can keep the same. So now you can see that the negatives will cancel out. So this will equal 2x plus 5 over x minus 5. And we can't factor or simplify anything, so this will be our final answer. In the second problem, we'll want to factor each denominator first. So we can use the x method. On the top is going to be negative 2, and on the bottom is negative 1. So all I'm looking at is this part here. So we're looking for two numbers that will multiply to negative 2 and add to negative 1, and that would be negative 2 and 1. And on the top would be x. So this is going to factor into x minus 2 times x plus 1. Next, for this denominator, we can use the same method since it's not any of those special cases. So on the top is going to be 6, on the bottom is negative 5. So we're looking for two numbers that multiply to positive 6 and add to negative 5. And that'll be negative 2 and negative 3. So this will factor into x minus 2 times x minus 3. So our least common denominator is going to equal x minus 2 times x plus 1 times x minus 3. So since they both have x minus 2 right here, we don't have to write that twice. So that means in the first fraction, we're missing a x minus 3, so that's what we have to multiply on the numerator and denominator. And in the second fraction, we're missing a x plus 1, so that's what we're going to multiply in the numerator and denominator. So for the first term, the numerator is going to become x minus 3, because 1 times x minus 3 is x minus 3. And we have our LCD as the denominator. And in the second fraction, we have x times x plus 1. Next, we can combine this into one fraction. So that'll be x minus 3 minus x times x plus 1 over the LCD. And next we'll want to simplify the numerator. So I'm going to multiply, or I'm going to distribute the negative x. So this becomes x minus 3 minus x squared minus x over x minus 2, x plus 1, x minus 3. And in the numerator, we can simplify the x's. X minus x is going to be 0. So then we're left with negative x squared minus 3 over the denominator. In this one, we can't simplify the negative because there's no negative in the denominator to simplify. So you can leave this as your final answer. Or if you want to, you can also factor out the negative. So if you prefer, you could write negative x squared plus 3. So this here will be the final answer. Okay, number 7, this one we have a complex fraction. So there is a fraction within a fraction, and I'm using this line as like the divider of the big fraction. So we're looking at the denominators of each half of the big fraction. Hopefully that makes sense. So in the numerator, we just have x minus 4, and there are no denominators, so we don't have to look at anything there. But in the denominator of the big fraction, we have a denominator of 4 and a denominator of x. So that means our LCD is going to be 4x. So we're going to multiply the big fraction by 4x. And if it helps, this pink line is going to be what separates the numerator and denominator. So in the numerator, we're multiplying x minus 4 times 4x. And in the denominator, we're multiplying 4x and distributing it to each of these. So x over 4, here, let me write that on the side. X over 4 times 4x. The 4's can cancel out, so we're left with x squared. And that's going to be the first term in the denominator. And in the second fraction, we have negative 4 over x times 4x. So the x's can cancel out, and we have negative 16. So we have 4x times x minus 4 over x squared minus 16. Next, we want to see if we can factor anything. So in the denominator, this is a difference of 2 squares. So that's going to factor into x plus 4 and x minus 4. So the x minus 4's can cancel out, and we're left with 4x over x plus 4. And we can't factor or simplify anything else, so this is going to be the final answer. In number 8, so here is the line that separates the two fractions. So we're going to look at the denominator of the numerator, so that's going to be x plus 2, and the denominator of the denominator is x plus 2 squared. So that means the least common denominator is going to be x plus 2 squared. So we're multiplying both numerator and denominator by x plus 2 squared. And this line here is the separation. Okay, so looking at the numerator, this will be x squared minus 1 over x plus 2 times x plus 2 squared. So we can cancel out one of the x plus 2's and we're left with 1. So that means the numerator is going to be x squared minus 1 times x plus 2. And then looking at the denominator, we have x minus 1 squared over x plus 2 squared times x plus 2 squared. So the x plus 2 squareds will cancel out, so that means we're left with x minus 1 squared. So that's going to be the denominator. Next, we want to see if we can factor any more. So x squared minus 1, this part here, this is a difference of 2 squares. So this is going to factor into x plus 1 times x minus 1. We still have the x plus 2. And in the denominator, we can't factor that more, so we can leave it as x minus 1 squared. So in the numerator and denominator, they both have an x minus 1, so I can cancel out one of those. So that means we are left with x plus 1 times x plus 2 over x minus 1. And we can't simplify anything else, so this is going to be the final answer. Okay, the last part is factoring with negative and fractional exponents, so you want to factor out the smallest exponent. So looking at number 9, I'm going to first start with the numbers, so 3 and 5. There's nothing I can factor out from 3 and 5, so I can't factor a number out. And looking at the exponents, we have an exponent of 4 and an exponent of negative 3. So the smaller one is negative 3. So that means I can factor out an x to the negative third power. So in the first term, which is this part here, if I take out x to the negative 3, I'm left with 3x, and now I have to figure out the exponent. So our original exponent was 4, and I'm going to subtract what we factored out. So 4 minus negative 3. And that'll equal 7, so the exponent for x is now going to be 7. And a way to check is to distribute x to the negative 3 back in. So x to the negative 3 times x to the 7, since we're multiplying and they have the same base, we're going to add the exponents. So negative 3 times 7 is 4. Okay, now looking at the second half, we still have a minus 5, and we factored out all of the x's, so that's it. So the final answer is going to be x to the negative third power times 3x to the 7th minus 5. For number 10, again, we're first going to look at the numbers. We have the or the coefficients, we have 4 and 6, so we can take out a 2. And now looking at the exponents, the smaller one is 1/2. So now we're factoring out 2x to the 1/2 from each. When we factor out 2x to the 1/2 from 4x to the 3/2, we're left with 2x, and now we have to figure out the exponent. So the original exponent was 3/2, and we're going to subtract what we factored out, which was 1/2. So that'll equal 2/2, which is 1. So we have an exponent of 1, which means we don't have to write anything. And in the second term, we have a 3 left and no x's left. So our final answer is going to be 2x to the 1/2 power times 2x plus 3. In number 11, we're going to use the same method. If it helps, I'm going to replace 2x minus 3 with y. So I'll show you this method for this problem and then another method in the next one. So I'm just setting y as 2x minus 3. So this will become 6y to the 1/3 minus 3y to the 2/3, negative 2/3, sorry. So this is going to be my new problem. And we can use the same concept as the first two. So looking at the coefficients, we can factor out a 3. And looking at the exponents, I would want to factor out a negative 2/3. So in the first term, this one here, I would have a 2 left and a y, and I have to figure out the exponents. So that'll be 1/3 minus negative 2/3, which is going to equal 3/3 or 1. So it's going to be 2y to the first power. And in the second term, this one here, we're left with negative 1. So our original problem doesn't have any y's, so now we want to go back and replace the y's with 2x minus 3. So this will be 3 times 2x minus 3 to the negative 2/3 times 2 times 2x minus 3 minus 1. So in that step, I replaced y's with 2x minus 3. And inside the parentheses here, I can distribute the 2 and simplify. So nothing else is going to change. And I get 4x minus 6 minus 1. And here I can combine the negative 6 and minus 1. So this will be 3 times 2x minus 3 to negative 2/3 times 4x minus 7. And this will be the final answer. Okay, in number 12, so in this problem I'll show you without replacing with y. So they both have 5x minus 2. So looking at the coefficients, we have a 7 and a 3. We can't factor anything out. Then there's an x squared and an x, so I can factor out an x. And they both have 5x minus 2. One is to the 5/2 power and one is to the negative 3/2 power. So that means I can take out a 5x minus 2 to the negative 3/2 power. So they both have this term with an exponent, so that's why I can factor that out. Okay, so in the first term, this part here, I can factor out, or I would be left with 7x, and then we have to figure out the exponent. So 5/2 minus negative 3/2 is going to equal 8/2, which is 4. So that'll be 5x minus 2 to the 4th power. And in the second term, I'll be left with plus 3. And from here, I just want to move it down a little bit so there's more space. Okay, and then from here, there's nothing else we can simplify, so this is going to be the final answer. And you don't have to multiply out 5x minus 2 to the 4th power, because that would take a really long time. And you can't simplify anything with 3 anyways, since we're multiplying by 7x. Okay, last two. So number 13. I noticed that they all have 4 minus x squared. So let's first factor the numerator. In the numerator, we can take out a 4 minus x squared. And the power that I would want to use is -1/2 because that's smaller. And there's nothing else we can factor out. So for the first term, this one here, we are left with 4 minus x squared. And then we have to figure out the exponent, so that's going to be 1/2 minus -1/2, which is going to be 1. And in the second term, we're left with x squared. We can't do anything in the denominator, so we'll just leave it as 4 minus x squared. Okay, inside the parentheses, we're not distributing anything, but we can combine -x squared and x squared. So that means for the numerator, we're left with just 4 times 4 minus x squared to the -1/2. And since both of these have a 4 minus x squared, we can rewrite it as 1. So since this has a negative exponent, I'm going to bring this down to the denominator. So this will be 4 over 4 minus x squared to the 1/2 power times 4 minus x squared. And again, since they both have the same base of 4 minus x squared, we can add the exponents since they're being multiplied. So this will equal 4 over 4 minus x squared to the 3/2 power. And we can't simplify anything, so this will be the final answer. Okay, and then this last one, we want to factor the numerator and then see what we can do in the denominator. So in the numerator, they both have x squared minus 2. The smallest power is going to be -1/2, so that's what I'm going to factor out. And there are no other terms I can factor out. So in the first term, we will be left with x squared. And in the second term, we are left with x squared minus 2. And again, to figure out the exponent, that'll be -2 minus -1/2 minus -2, which will equal 1 over x squared minus 2. So since this has a negative exponent, I can bring this down to the denominator, and I can also combine x squared and x squared. So that'll be 2x squared minus 2 over x squared minus 2 to the 1/2 times x squared minus 2. They both have the same base, so we can combine that into 2x squared minus 2 over x squared minus 2 to the 3/2. So we're adding the exponents, 1/2 plus 1. And then this will be the final answer. If you wanted to, you could factor out a 2 from the numerator. But even though we can continue factoring, nothing's going to be able to be canceled out. So x squared minus 1 is a difference of 2 squares, so this is if you need to factor completely.